Welcome to the last lecture of this chapter number 2, that is Pythagoras theorem. Very lengthy sum. This sum may not be asked also because maximum weightage is of 4 marks in your paper, and if you keep on solving this sum, I don't feel that even it is more than that. Anyway, so please try to understand. Given quadrilateral ABCD is a trapezium. This ABCD is a trapezium, and in this trapezium you will find this is 15, this is 15. Question asked is find out the area of trapezium, and you all know to get the area of trapezium formula is half sum of the parallel sides AB plus DC into the perpendicular distance between them. We don't know so far DC because they have given AB as 25 as well as AD and BC they have given at 15, and the question asked is find out the area. So we have to find out CN, we may have to find out DN, which is height or perpendicular distance between these two parallel sides, and we also have to get DC because AB is given, AB is not an issue. Trying to understand again, we have to find out the area of trapezium, which is half the sum of the parallel sides. This is not given, I got it and I have written over there. As well as this CN or DN is distance between parallel sides, which is also not given. I got it, that's why I have written. Okay, let's begin now. So we will find in right angle triangle ACB. This is right angle triangle ACB. I am going to use theorem of Pythagoras. So AB square, this is very important. This is 90, therefore AB is a hypotenuse. This is 90, therefore AB is a hypotenuse. So AB square is equal to BC square plus AC square. AB square is equal to BC square plus AC square. AB is 25, this total is 25, is equal to AC square. AC we don't know, but BC is 15, so 15 square. 15 square is 225. If I transfer it to the left hand side, 625 minus 225 will give us AC square. We will get AC square. If we get AC square as 400, the root of that is 20. So we got AC as 20. You must be thinking that why I am finding out AC. What was my interest to find out AC? Try to understand. If I get AC, then you will find AC. Then triangle ACB. ACB is a right angle triangle. So area of ACB is equal to half AC into BC. Area of ACB is half the product of perpendicular sides. That is formula to get area of right angle triangle. So half AC into BC. So 2 10s are 20. So I got area of ACB. ACB as how much? 150. At once you will get the area of ACB. Try to understand what I am saying. At once you will get area of triangle ACB. I am going to find out CN. You will say how to find out CN? Because triangle ACB you can see this way as well as you can see this way. One time you can consider AC as a base and other time you can consider AB as a base. This is very important. This is very important to understand. Next time I am going to consider AB as a base and CN as a height, and I will get CN because area is not going to change. In any way, area is not going to change. Triangle is going to remain same. This way ACB as well as this way ACB is one and the same. Triangle is not going to change. This is very, very important to understand. First of all, I find AC, then I got the area of ABC. Now I am going to consider AB as a base and CN as a height, which will give me CN. because you will find ACD and 150 half AB. Okay, AB also I know. AB is the base 25 into height. Height is always drawn perpendicular on base. This is very important to get CN. Why we have to get CN? Because this is a distance between parallel lines which we have to use for finding out area of trapezium. So you will get over here 150 is equal to half into 25 into Cn. So I transfer this to the left hand side, 150 into 2 upon 25. So Cn is 12. Cn is 12. So if I get Cn is 12, I have written it. So now very important thing, I got distance between parallel lines, because area of trapezium is equal to sum of the parallel sides. Sum of the parallel sides into distance between them. So you will find I got Cn as 12. Distance between parallel sides. Okay. Now still one thing is left out. Length of DC below. Okay. Now please look here. If I know Cn, I can find out N. Once again you will think, what is the use of finding out to C? What is the use of finding out N? You will come to know. So now I know CB, I know Cn by theorem of Pythagoras. CB is hypotenuse opposite to 90. Opposite to 90. So BC square is equal to Cn square plus Bn square. BC square is equal to Cn square plus Bn square. BC is 15, given, that is given. So 15 square is equal to Cn. Cn we got it as 12. 12 square. So 225 minus 144 is equal to Bn square. Difference between these two is 81 is equal to Bn square. So Bn is equal to 9. What is the use of getting Bn? That is very important. Now at once you will get Bn. Try to understand triangle CNB and triangle DMA are congruent. They are congruent by hypotenuse side theorem. How I will explain it. You will find BC and DA are congruent. They are hypotenuse. They are hypotenuse. Correct? And DM and CN are the distance between same two parallel lines. DM and CN are the distance between same two parallel lines. Therefore, triangle DMA is congruent with CNB by hypotenuse side theorem. What is the use of this? Use of this is NB is 9, therefore N is also 9. NB is 9, therefore N is also 9. Now, next to that, 9 plus 9 is 18. Total AB is 25. Total AB is 25. 25 minus 18 is 7. This total AB is 25 minus 18 is 7. And MN is 7. MN is 7. If we get MN, very very important, you will get DC also. Because you will find DMNC is a rectangle. Why it is a rectangle? Because this is 90. Why this is 90? Interior angles are supplementary. Because DC is parallel to. If it is a rectangle, MN is 7, DC is 7. At once we will get DC as 7. Rest of the part is easy because half the sum of the parallel sides into height, which is 12. We can get it. Very lengthy sum, I don't understand. So many times we have to use theorem of Pythagoras, as well as we also need to understand the concept. Okay, so you will find once again, you see, I have a brief look at this. I am going to repeat this all things again. This is 25. A, C, B. I use theorem of Pythagoras over there. So you will find AC I find out. This is 625 minus 225 is 400. AC is 20. Product of 20 into 15 upon 2. That will give me area of triangle ACB. I use the area of triangle ACB to get CN. So half base into height. 150 is equal to 150 is equal to AB into half CN. AB into half CN. So here you will find 150 into 2 upon 25. CN is 12. At once you will get CN. You can find out, apply the theorem of Pythagoras to triangle CN. You will be getting N. These two triangles are congruent. So therefore this is 9, this is 9. You will be getting 9 plus 9, 18. So total is 25. 18 minus 25 is 7. 25 minus 18 is 7. So quadrilateral DC and M, I'm going to write now. Quadrilateral. Quadrilateral D, C and M is a rectangle. Is rectangle. Therefore, if it is a rectangle, we will be getting MN is equal to DC. That is equal to 7. Opposite sides of rectangle. Opposite sides of rectangle. We have come to close to the final result. So you will find area of quadrilateral ABCD is equal to half sum of the parallel sides, that is AB plus DC into CN. Sum of the parallel sides into perpendicular distance between them, that is 7 plus this is 25 into 12. CN is 2. Here you will find 2 6 are 12. 32 into 6. 25 plus 7 is 32. 6. So this is how we will be getting the area of this trapezoid as 192. I can understand. Very difficult. So many times we have to use theorem of Pythagoras. Of course, as I explained it, practically it is not fair to give maximum 4 marks to this sum, but can't say. The sum may come in the examination also. Only this concept to understand, to get AC and then find out the area of triangle ACD. I am using the same area to get the value of CN, then to apply theorem of Pythagoras here to get NB as 9, this as 9, this is 7, this is 7. That's it. Okay. So 3 more sums are left out. Next sum is also very important. Next sum is also very important. Sum next one is important, dear students. That sum is also the next one, that may carry also 4 marks only. Equilateral triangle is given. Calculations are given. Okay. So you find triangle PQR is given over here. Triangle PQR is there. Question number. This is question number 16. Last lecture of this chapter. Triangle PQR is given. PT is there. PT is there. PS is also there. Fine. This is 60-degree angle. This is also 60-degree angle. Name of the triangle is ABC. Then you will find PS is there. Okay. PQR. Name of the triangle is PQR. T is given. Please make a correction in the textbook if it is not given 90. It is perpendicular. This is S, and we have to prove. It is given QS is 1/3 of QR. Okay. QS is 1/3 of QR. Prove that. 9 PS square is equal to 7 PQ square. 7 PQ square. 9 PS square is equal to 7 square. Entire figure it is given, triangle PQR is there, PT is perpendicular, and simply I am not sure whether length of PQ is given or not, okay, or any one of the side is given or not. I am simply confirming it and then I'll come back. Okay, no issue as such. No dimensions are given. Fine. Okay. Now please try to understand. Now this QT is equal to half QR. Please try to focus on the final result, PS square and PQ square. So what I am going to do, I am telling you very simple way. I am going to find out PT. I am going to find out PT because I have to get PS square. So I will find out the value of PT as well as I will find out the value of ST. That is very important. What I am going to find out? PT and ST. Please focus on this anyway. So QT is equal to half QR. Right? Why? Because T is midpoint. T is midpoint of QR and PT is perpendicular to QR. Why this is so? Because in equilateral triangle, that midpoint, the perpendicular or height bisect the base. Height bisect the base. Please try to understand. QT is equal to half QR. Okay. Now, please try to understand. QT is equal to half QR. QS is equal to 1/3 QR. QS is equal to 1/3 QR. Very important. This is given. And my aim is to find out ST. Why to find out ST? Because I am going to apply theorem of Pythagoras to triangle PST. That is very important. That is very important. So QS is 1/3 QR, QT is. What is my aim? To get ST. Please try to understand this carefully. I am going to apply theorem of Pythagoras to PST because I want PS square. That's all I know. Fine. Now please look here. ST is equal to QT minus QS. QT minus QS. That is equal to ST is equal to QT minus QS. That is equal to QT is how much? QT is given there. QT is QR upon 2. QR upon 2 minus QS is how much? QR upon 3. QR upon 3. That is equal to 3QR minus 2QR upon 6. 3QR minus 2QR upon 6. Cross multiplication. So ST is equal to 3 minus 2 is QR upon 6. QR upon 6. Is that clear? QR upon 6. But QR is equal to PQ. But QR is equal to PQ. Why? Triangle PQR is an equilateral triangle. Triangle PQR is an equilateral triangle. All sides are congruent. All sides are congruent. And why? To express QR in terms of PQ, because final result is in PQ. Final result is in PQ. Very, very important. So you will be getting ST is equal to PQ upon 6. ST is equal to PQ upon 6. Again, I am telling you, I am going to apply theorem of Pythagoras to PST. I got ST as PQ upon 6. PT is height of an equilateral triangle. PT is height of equilateral triangle, which is root 3 upon 2 into sine. Root 3 upon 2 into sine. Very important. PT is the height of an equilateral triangle. Root 3 upon 2 times PQ. Why again I have taken PQ? Very simple. That final result I want. Now I got ST, I got PT. Finish. So in triangle PST, in triangle PST, by theorem of Pythagoras, by theorem of Pythagoras, by theorem of Pythagoras, PS square is equal to ST square plus PT square. ST square plus PT square. PS is hypotenuse. In triangle PST, PS is hypotenuse. So PS square is equal to ST. What is value of ST? PQ upon 6. PQ upon 6. The whole square. What is value of PT? Root 3 upon 2. PQ whole square. Please do the calculations carefully. PS square is equal to PQ square upon 36 plus PQ square upon 36 plus root 3 square is 3. 3 PQ square upon 4. So PS square is equal to LCM is 36. LCM is 36, and you will notice 36 is already here. So PQ square. 4 nines are 4 nines are 36. Multiplying this by 9. Now, if you don't know this, I am sorry. After taking LCM is 36, so PQ square as it is. 4 nines are 36. So 9 3s are 27. So PS square is 28 PQ square upon 36. So if you minimize them, 4 7s are 4 9s, 9 PS square is equal to 7 PS square. Okay, dear students, please try to understand. Very important sum from examination point of view. So first of all, you will find I try to get ST as well as PT in terms of PQ. So first of all, you will find that QT, this is perpendicular, it is not mentioned in the textbook, but please make a correction. So you will find QT. QT is half of QR. QT is half of QR. T is a midpoint of QR, PT is perpendicular. ST. Now QS is given 1/3 QR. QS is given 1/3 QR. My aim is to get TS. ST is equal to QT minus QS. QT minus QS. QR upon 2 minus 3 minus 2 upon 6. 3 to the 6. ST is QR upon 6. But QR is equal to PQ. Why to express in terms of PQ? Because finally I have to get it. Okay. So ST is PQ upon 6. PT is height of an equilateral triangle. Root 3 upon 2 times side. I have taken again PQ because final result in terms of PQ. Applying theorem of Pythagoras. PS square is equal to ST square plus PT square. ST is PQ upon 6 plus PT is root 3 upon 2. PQ square upon 36 plus 3 upon 4 PQ square. Here LCM is 36. 36 is already here, PQ square as it is. But to get 36 here, you have to multiply 4 by 9. So you will multiply numerator by 9. That is the method. That is the method. Okay. So 9 3s are 27 plus 1 is 28 upon 36. If we minimize 7 upon 9, 9 PQ square, 7 PQ square. Very important sum. This may get surely for 4 marks, right? Because you will find not so many steps are here. Very important to understand these things. Okay. Please note down quickly. I'm taking a little bit break just to have a look at this. Last 2 sums are left out. Okay, fine. 17th question. Question number 17. These both questions are based on Apollo list there. Pn is a median in triangle PQR. Okay, fine. So I'll draw triangle PQR is here. PM is given as a median. PQR is a triangle given. PM is the median. Okay. PM is the median of triangle PQR. PQ is 40. Fine, very good. Next to that, PR is 42. PR is 42. PM is 29. Big numbers are here. Find out QR. Find QR. Okay. Find QR. So it's simple, but only big numbers are there. In triangle PQR, by a harmonious method. By a harmonious method, PQ square plus PR square is equal to twice PM square plus twice QM square. Twice QM square. PQ square plus PR square is equal to twice PM square plus twice QM square. PQ is 40 square plus 42 square. That is equal to 2 into 29 square plus 2 into QM square. 40 square is 1600 plus 42 square. One 764 42 square, that is equal to 2 into 29 square is 841 plus 2 QM square. Okay, so this is 4 6 3364. That is equal to 1682 plus 2 QM square. You have to be careful while adding these numbers. 4, 6, 13 carry 1. Now transfer this. 3364 minus 1682. That is equal to 2 QM square. Big numbers are there, that's all. One 682 is equal to 2 QM square. Difference between these two. Only the numbers are big, that's all. So 1682 upon 2. That is equal to QM square. So 841 is equal to QM square. QM is equal to root of 841. So QM is equal to 29. If units are given, then good. If not given, then also. Then you will find, question is find out QR. QR, M is a midpoint, so twice square. That will be 2 into 29. That is equal to 58. If it is centimeter, well, good. If not, then you are simply say units. So here you will find it. Here you will find we finished to get. Units are not there. Simply I am writing centimeter. It's okay, or you may not write also. One of the same. This is Apollonius theorem. Only the big numbers are there. That's all. So PQ square plus PR square is equal to twice QM square plus twice PM square. So 40 square PQ, 42 square is equal to 2 into 29 square plus 2 into QM square. 40 square 1600. 42 square is 1764. Sum of them is 3364. 841 into 2 is 1682. Transfer it 1682. You will get. So here 2 qm square. If you transfer to 841, square root of 841 is 29. So qm is 29. Of course, qr is twice of that. So 58. Okay, let's do the last sum of this chapter. Please have a look quickly. Okay, last sum now. Last sum of Pythagoras theorem. As you, after this chapter, you will be getting a test of 40 marks. You can even refer reliable sales book and solve that. I think you all know it is very, very important to complete your notes. Otherwise, it is only one way of teaching. I am not giving you a single sum. I am stressfully telling you I have not given single sum to solve you as homework. All sums are done. So your job is only to copy these sums. So n is a median of triangle ABC. Okay, I am going to draw the figure. N is a median of triangle ABC. Please have a look. N is a median. N is a median of triangle ABC. Next to that, it is given AB is 22, while that of AC is 34, BC is 24, BC is 24. Question is find out AN. Fine. We have to find out AN. Same way, very simple. Find AN. Find N. So by in triangle ABC. By opponent is said. Here you will surely notice that we have to use Apollonius theorem. AB square plus AC square is equal to twice AM square plus twice BM square. AB square plus AC square is twice AM square plus twice BM square. 22 square plus 34 square. That is equal to twice AM square plus 2 BM square. BM square. 22 square plus 34 square is twice AM square plus 2 into 12 square. 22 square is 484. 484 plus 34 square. 1156. 1156 is the square of 34 is equal to twice AM square plus 12 square is 144 into 2. Okay. So addition of these two is 1640 twice AM square plus 288. 144 into 2. So you will find 22 square plus 34 square. sum of these two. Okay. Now transfer this 288 to the left hand side. That is equal to 2am square. And subtract this. So 1352 is equal to twice am square. So 1352 upon 2 is equal to am square. I transfer this to the left hand side. So we'll find is equal to am square. 676. Square root of 676. Square root of 676 is 26 is equal to units are given or not, I don't know. Okay, our units are not given. So maybe an n is 26 units. Okay, so here you must know the units also. Sorry, squares also properly. Fine. Please have a review of this sum. By Apollonius theorem in triangle ABC, AB squared plus AC squared is equal to twice m squared plus twice bm squared. Total is 24. This is 12. So 22 square is 484 plus 34 square is 1156. If you add these two, you'll be getting 1640. 2m square, 144 into 2, that is 288. Transfer to the left hand side. 1352 is equal to 2m square. Difference between these two. If you divide it by 2, you'll be getting 676. So you will find root of 676 is m, that 676 is a square of 26, so m is 26. Dear students, I finished this chapter. Pythagoras theorem. Please have a look at this sum. This is one of the very easy chapter. Very easy chapter. Theorems are also very important because theorems may be asked for 4 marks also. Last questions are little bit difficult to understand. But for scoring purpose, this chapter is very good. For 3 marks or 2 marks question, very easy questions are there. So this is how you will find I have finished. More or less, you can say 4 chapters. Around 2 chapters are left out. That is circle. Circle is very important, very big. Weightage is also very high. So from the next lecture, I am going to give you that. From my side, I am very clear. I am not given you single sum as homework. From your side, I don't. If you are sincere enough, you are disciplined enough, you will be copying all these sums regularly. You must be revising these videos regularly. If not, you are unfortunate. And my conscience tells I have done my job very, very sincerely and in very disciplined manner. Thanks a lot for cooperating, for listening this video as well as for watching this video. Thank you very much. I pray for all of you. God bless you all.